Probability, Part 3, Independent Events. We say that two events, A and B, are independent if the occurrence of one of the events does not change the probability of the other event. Let's examine two events. A, you wear a blue shirt to school. B, you are late for school. Obviously, these two events are independent. That is, the color of your shirt will not affect whether you are late for school and vice versa. Now let's look at two other events. A, you can't find your keys in the morning. B, you are late for school. Well, it is clear, I think, from this that, let's see if I've written anything out. No, I haven't. I'll have to go back and just explain it. If you can't find your keys in the morning, it's going to change the probability of whether you're going to be late for school. So these events are not independent. We say they are dependent events. And here we get down here to the AND type probabilities. The probability that event A and event B occur is the probability of A and B, which equals the probability of A times the probability of B, given that A has already occurred, where the probability of B/A means that the probability of B occurring, given that A has already occurred, as I earlier said. This is called conditional probability. The slash means given. So it's not the probability that B will happen, but since A has already happened, it may affect B, and so that's the probability of B given that A has happened. If the two events are independent, then the probability may be reduced to just probability of A times the probability of B, because it doesn't matter whether A has happened in independent events. And I have a real short little problem here. Getting back to the balls in the urn. With replacement, find the probability that with two draws you will get a yellow ball and then a red ball. Replacement means you reach in and you pull a ball out, a random ball out, and then you observe what it is, and you put it back, and you shake the thing up again, and you pull out another ball. And the thing about pulling out two balls out of an urn with replacement is that they are independent events. So we can reduce this very easily to probability of a yellow ball and a red ball equals the probability of a yellow ball times the probability of a red ball, because these two events are independent. Well, the probability of getting a yellow ball, it's pretty clear on the first draw, is 2 out of 5, isn't it? So we'll put 2 here, 5 here. And then the probability, then you throw the ball back in, you draw again, the probability of getting a red ball, well, there are 3 red balls out of 5, right? And there's still 5 balls in there because we replaced the first one. And of course we get 6/25, don't we? And there it is. In the next part, we'll look at the same thing, only the events will be dependent.